All right, thank you so much for attending last talk of the day, last talk is Summit in North 2024. I really thank for all of you. And I hope it's going to get benefit to you. Maybe I will scare you. Maybe, maybe not, we will see. So before starting, and again, I'm going to talk about the software supply chain for SDV. Anybody knows what's SDV? Software-defined vehicle. And actually, I'm going to say software-defined everything soon. It's not a vehicle anymore. It's going to be software-defined everything, even though our phone will be software-defined eventually. And then even though aircraft probably will go that direction, actually, maybe I'll start early. FAA, they already approved some of the autonomous aircraft that can be configured while aircraft is in the air if it is autonomous. Now, if there is no human in it, it's already processed and approved. It's actually start with a drone. It's going up, so it is getting there. So it's going to be software-defined everything. So I'm going to change it SDV next time, make it SDV, SDE. All right. So what I'm going to talk about really, it's about me. I don't want to go. You can read it later on. I really talk about the why matters, why is important, why we are here. What I'm going to really talk about SDV, what the components are. To understand also, we're going to think about really what is the safety and security, what is the supply chain means in OEM parts, how can we make it available and we can have a trusted or a secure systems eventually. So we can look at SDL. So we can also look at how are we building those bill of materials within the supply that within the component that we do. That's what I would like to cover again. But also at the same, since we are small groups, we can discuss and talk. I don't want to wait at the end. It's good to have conversation, make you awake, make your interaction, make you get out of it here. So again, I want to make sure that you are taking something that you're interested and have a conversation with us. I like that conversation. So why matters? Let's go quickly. This is the car. Thanks for the cake. But we are adding a lot of things in the car. In all this, we're just buying a car, right? Now with the car, we are getting everything. Eventually, we get all the components together. So when we look at the cars, if I look at my car journey, actually, my first car I bought in US 1996 was a Ford Taurus. It was a fantastic car for me. You know, it was the stick shift. I was happy. The next car had a little bit more software in it. The next car I bought it like, again, maybe a little bit advertisement. Actually, thanks to Honda, I bought a Honda Odyssey. Was that car has the infotainment in it. There's a nice videos and the cameras, and then kids like it. They were using the cell phones and the headphones actually in the car. And nobody asked me. My first daughter was asking me, hey, are we there yet? So when I have that car, it's a minivan with the headphones with the nice video systems in it. And other two kids never asked me, are we done yet? Are we there yet? They just looked on. So that's kind of what is happening right now. The car became our life, kind of where we see. But when we look at the car right now, it is more configured many items. Now we have AI in it. Lane assist driving as an example. Infotainment is an example. Most scary part for the cars for me actually updates. So what is really ingredients of any software, any car that we have? We have to really start from the thinking, yes, it looks like a something, but what is really inside the car that we are taking? So when you categorize, we see a hardware, software, and training data sets, and then the communication. So yes, there is a hardware chassis. This portion is getting actually lesser and lesser. So I'm going to say a couple of examples. Like we are getting a hardware unit, but it's actually the traditional BOM, and there's a CPUs, and then some other components, and also getting a spare part is which is third party. We're getting it. So this portion is really getting much lesser in the new vehicles that we are purchasing. If you go to electric vehicle right now, and if anybody's a Tesla driver, but you have a Tesla here, you have Tesla? Sorry, I'm going to attack you a lot. I'm sorry. So Tesla, this is the story from Tesla engineers, by the way. They have a same chassis with the engine, same motors. It looks like we're different as the shape. What is really the difference is the software. So based on X, Y, Z, we are paying money for the software. The same car, but we are paying software differences. Same thing for many car manufacturers as well. So that hardware piece is becoming more abstract. If it's becoming more abstract, what is really driving? Rest is driving the software, which is more components we are adding into it. That components is communicating with others. Now we have AI in it. We have a data collection. We have engines running on it. So we have a data set that we use from the data center, which goes back to Tesla again. There is a digital version of the Tesla car running in the Tesla data center. And this is what is happening is actually helping to how you drive the car based on your behavior as a driver, and cars get updated based on the parts, OEM parts, based on the software you're getting it. So it's basically, it's becoming more categorized, more configured based on our driver, based on our choice, and based on the software. So now we're adding other components, the communication sensor. When you look at this perspective, this is kind of a component that we have in the car. So what's happening, again, when we look at today's landscape, we have more for the SDV from the BlackBerry. So we see more of the millions of lines of software in ECU. So we're expecting see bill of materials by 50% in 2030. We're very close, like 5 years ahead. Based on we're expecting so many bill of materials, maybe I should get down, probably I really can see, I can see as well. It's really getting very important. We have less than 10% of vehicle bill of materials, which is increased by 50% by 2030. That's the direction. Why? Because we see a lot of components in the car that we are building. Because it's very cost effective, and most of the car manufacturers, I have been supporting many SDV communities in Europe as well as in the US, it's becoming more integrators. We don't want to build everything by ourselves. Isn't that the same thing for the software? Like, yeah, it's basically when I say, can you write me a hello world in web application? It looks like very complicated. Writing a hello world in web application is much simpler than writing a hello world in C++. You know why? Because hello world in the web application, engineers, they don't need to do everything. They're just gonna grab that component, this component, bring it, make it a one line of code, it's ready to go because it's all already done as the behind the scene. When you're writing something from scratch as the C++, you have to compile it. When you write a hello world in the printf, you have to compile it with extra steps. So with this analogy, we see a lot of component, the software-defined vehicle is getting a lot because much easier. First. Second is we can use the same component multiple times in the pipeline, which is the money part of it. It makes much easier. Let me go up. It's not working here, it seems. So when we look at those elements, we would like to go and save the human life. That's our goal. We would like to save human life, make sure that we are saving the human, we can automate it. So the purpose of this software, it's been built really stopped at any crash, like a lane departure assist is an example. Or maybe you're following some features in the car, which is great, fantastic. To protect the human, to give the lane departure warning, maybe the lights on the mirror, give idea for you to protect it. Maybe if the car is not responding for emergency response, maybe predictive maintenance, which is Tesla does a lot. It's make it more personalized, which is the good benefits. And another things, we are getting car update over the air. Anybody is getting over the air update in your garage. When you turn on the car, it says, I have the update, with Tesla does. Most of the car actually does. Like BMW does, Mercedes does, and then Toyota does. Most of the car is getting over the air updates. Again, I don't want to scare you, but yeah, which we'll talk about it, makes much easier. But is that really secure? Is that really secure? Are we going to trust all these things? It's going that direction. But how much we trust those components? Actually, it's not. There are a lot of stories. This is more specific Tesla. I'm going to share a couple other articles as well. We have so many incidents happening because you may say everything is autonomous, should be much better. Actually, it is not there yet because still human in the loop every time. Maybe you can take the human out of completely. You may think about everything will be safe. But human is in the car all the time. Human is on the street because unpredictable. Whatever you do, whatever you train, still there are a lot of failures happening. That's what happened in the Tesla case with autopilot crash and fatality happen. More things happen as happening right now. Actually, this one, I just got it a couple of days ago, which is Venmo. That happened June 20th. Today's 25th in San Francisco. Venmo caused a fatal accident. Anybody draw the Venmo? I was in the Venmo when I was in an RSA conference. Again, I'm not blaming the company. What I'm saying it's a potential failure is happening with the car that what we see. Because again, there's a lot of moving parts around it. The car manufacturer, they would like to really build up a secure system, which is perfect, but there are a lot of components in it, we should realize that. Another statistic from NSD, and going back here, there's a lot of statistics here, which is getting more crash, and we can see the graphics as well, and it's keep increasing. Recent statistics, again, from the Consumer Shield. This is really interesting. We have more crash on the software-defined vehicles, more autonomous vehicles, self-driving, comparing regular vehicles, which is 9.1 versus 4.1 per million mile driven. So it makes maybe a small number, but when we have a human in the loop, it's very, very important thing about the safety, because we cannot justify, we cannot really say it's important, it's okay. So another things about the Tesla accidents, 73% is actually because of the autopilot beta. So why is it happening? Again, this is the software is in it. Software is part of it. So again, I think at the more we have more elements in the software, it's getting more challenging. So again, attack vectors keep increasing for any components that we have. So think about your software that you have as an attack vector. You're analyzing your web applications. When you get into the car, honestly, we have more attack vectors happening in the car than the web applications. Like our car is connected for many components, for your mobile, for your over-the-air updates, and for the components in it. It's so much components are running in this environment makes more challenging to get it. So now, with that challenges available, yes, there is a trend in the community. We would like to build up secure. Let's go back to the foundational. What is the bill of materials? Why is it important? Again, we can think about FDA. We're expecting cybersecurity bill of materials is available and should be used all the time, which is mandatory. Actually, recently, the consumer organizations, and also actually goes back to the trade departments in the US, they mandated bill of materials, it was not on the slide, but mandated this bill of materials as the required for any piece of components comes into the US, as an example. Which goes back to the CISA adding more bill of materials for everything. Now, taking the SDV concept, make it more connected. Now we see bill of materials is in everywhere is required. In the cyber physical system, communications, and everywhere. It's really affecting our life, honestly, right now. It's more than ever before. You think about the software as the car, but software is in everywhere. It's everywhere software right now. And also the software that we build, how are we building that? It's also depend on many components that we build. So let's take a look what is really going on wrong, what the problems that we are dealing. So we have more ingredients, more ways can go wrong. Again, I'm not saying we should stop it. When I say something like that, everybody says, no, we'd have to stop, go back to C++. No, we should go back to the moderate. But we have to really deal with the complexity. We have to navigate in complexity. Complexities are many components. Complexities are many different subsystems. So many softwares available. But we can navigate in this complexity to eliminate more ways can go wrong concept, which is possible. But we always think about go fast, which we discussed in the panel too if you attended. We would like to go more component level, more business, more functions, but we never think about what can go wrong. Isn't that the 101 thing cybersecurity says what can go wrong? What if? We do as a person in our life. We always risk analysis our life. But when we think about the system, we don't think like that. We don't really put the risk, what if scenarios. But we do in our life. Every time we work, what if I miss the train? Let me arrange my time. If I miss the train one time in the morning, next time I go early. So based on risk, we are able to mitigate that. But for the industry, we don't really mitigate that. So it's basically, we see software vulnerabilities in every components. Now with the AI and ML that we're creating in our components and environment, it's a big problem. If you look at the fatal cases in the SDV vehicle, it is about the training, because we cannot train everything. We have to improve the training content. We have to improve the elements. It's technically, the training piece is done more known sources. It's going to get much better, you may say, in the down the road, but how do we know that data science, anybody data science, data engineers in our discussion, in our group, anybody? So I can folks speak freely, maybe? All right, so data engineers, when they train the model, typically they're using an open source data source eventually to start. How we can trust those open data source that we can trust? Then we are using as a starting point, building up that modules, then put in the application context within the car, then try to train that model again. It takes extra time, but also how do I know that initially the model has actually used the right data sources? And how do I know the model is actually trained around an environment? There's a lot of questions that we need to address about the AI ML component, how it is biased, which is another one, which is ethics in it. So another one, the last one is about the more things can go wrong. Remote services. So now we have remote starts in the car. We have updates on the car. So one thing I can share, I want to say the company name, this is the true numbers. Most of the software-defined vehicle companies, the best one, they're able to update their software if there's vulnerabilities, cycle is 45 days. It's the true numbers. 45 days to take them to update the car that you're driving in the street as patched in a vulnerability. So that means your car is vulnerable for 45 days as a zero-day vulnerabilities, but car is not updated yet. This is the best one. Other one takes more than 45 days. Why? Because of many complex components together. Did I scare you enough? Maybe? Not yet. Still, we're going to drive the car. All right, we will, but we're going to continue. So let's think about what we can do. We know the problems, what we have to do as thinking. So we have to really think about the system engineering concept. If we think about the small components, that's what we fail. What is the system engineering concept? Is actually, maybe you heard about the V model. We really think about from a system, from the bottom up, go all the way up, try to integrate verification and validation every level. That's the problem that we should think about. If you look at the supply chain, we need to think about the verification and validation, every level, every component that we build up going up. Starting from top down is not working, and we're going to start bottom up. Analogy is, when you are working your home project, as an example, you go buy some electric component to your car for your home. You looked at the certification on the switch. But basically, every switch in the construction business is already verified, because the component is already verified based on the defined, based on the requirements, based on what the electric requirements looks like. It's certified. We buy the certain plug, it's certified, it's verified. So if you think about that perspective, we need to think about really each of the components and go and assurances every level. That's what we should start. We're going to start from the bottom up. That's basically what the future SDV looks like, starting the verification and validation, starting the security as in the pipeline, as in the smaller modules that we use. Smaller module, if we verified, we can connect together. Eventually, the system can be secure. When you try to from top down, it is very too late. Like top down means if I have something is running, it is too late to respond those vulnerabilities because it's individual. We always delaying the process. So analysis of the 45 versus the longer time to update, because first of all, each of the update didn't have its own process to update on timely, which takes longer time. Let's continue, which is another one, and it's starting in Japan. Now the organization are pushing more infrastructure security as the requirement, which is Japan started. Many organizations are building to build up the cyber physical infrastructure as part of it, right? Continue. So when we look at the safety standards, there is an excuse. As a community, we have many standards available. There are many standards. We don't miss the standards. We have so many things. We have IEEE, we have open, we have the open groups, we have an IUC, we have IEC, we have many standards. So as a community, we build up great standards. What is really missing here? We don't implement it. We don't implement means we don't implement, we sacrifice in the component level. We don't implement in the bottom of the component level. We don't really go to the level. So what we should do, we should really look at the supply chain, the metadata from beginning to end. We really have to look at what are the components are, how are we connecting components, try to really create a relationship between the components. Some integrators are really thinking, hey, I have components, let me try to get those components to look at the effects are, and then actually change some acquisition process as well. Like maybe I can name the Bosch company, which Bosch is one of the most integrated in the car manufacturers and OEM suppliers. They would like to build up the metadata around it, building up a safe usage requirements. But most important is requiring evidence is important. Evidence, we have to satisfy the evidence. Evidence should be level of the component. Now I'm going to give the credit for Tesla because is driving, Tesla is getting a certification almost 24 hours for a new car. Why they do? Because they are trying to certify in the component level. Because they have only the incremental changes is happening when they have a new car on the street. And every car is built in Tesla is unique, by the way. It's unique to that pipeline build, it's unique to the person. There's a digital representation in the data center because they are getting verification quickly because of the component level. They bring into the application and the metadata in the bottom, that's so they can improve much quicker, much faster. So technically, we need to think about software SBOM, think about the system level SBOM. That's the direction it should be. Why I'm saying it, again, starting from component, but we need to know where we are in the big pictures. And another thing I was talking with Kate, one of the big TV manufacturer company, the engineers, they don't know where is their firmware in the big picture in the components. They are building the firmware for a specific device in the entertainment, whatever the things they are building, but they are struggling to think about the dependencies of another component running the same firmware for the interfaces. Because they never think about the system level, they think about the pipeline. Why? Why they do? Because that's how we are building the systems. I'm going to show you what the build mechanisms looks like. We always start from the bottom, but we're not able to connect the dots. So that's what it started. So we have to think about, we need to standardize for the metadata, we need for the software supply chain. We should really ask ourselves, why? Why the software components are executed? What the software components are, the model was trained, how it is trained, where we are storing. There are many questions we should ask ourselves. Always you need to think about like a kind of a typical threat modeling concept. We need to think about what are the entities in supply chain that we have. If you are in the position that you're acquiring many components, you should always ask yourself, what are the ingredients, what are the metadata I needed, so we can put into our contract language. Or we can ask when we are receiving the code drops as an example, right? So making standardized metadata makes much more accurate, so we can collect the different data sets. So we have different SBOM. We have a design, which I'm going to come back shortly, design, source, build, and deploy runtime, which we can capture the many SBOMs or ingredients where we are building. When we assemble together, we can look at how the system is behaving as an intended behavior. So we're going to start bottom up. When we look at the pipeline, with the pipeline, we can generate those bill of materials pipeline automatically. When I say pipeline, that we are building the software and systems. We start from the system, we start the hardware. We know that software is much more part of the hardware that we have. So when we look at the software, when we are building any system, either a firmware that we build, maybe interfaces, maybe infotainment, it goes through the same cycles. Same cycles about the requirements, basically, requirements architect and develop and test and deploy, this is the same. Please do not think that any new modern way of building like a process agile or DevOps or DevSecOps or SRE or platform engineering, none of them is changing the phase of life cycle. We still have the same phase of life cycle. Even though you don't call it out, still we are following the phases as understanding the requirements, as designing and architecting, still we do. So when we look at that perspective, we have to really see what are the changes are, then I can collect different bill of materials where I am in, then where we can start. Again, going back to the definition of the CISAs, you can take a look later on, and which is what the design means, what the source means. Design is basically looking for intended version of the component. Source is, it's the source component that we are building as a code. Build is the build process, and then when we deploy, it's going to get in deployments. Like given a quick analogy, you are basically getting a libraries. That library, it's already compiled, maybe a DLL that you compile. To understand what the DLL, which is Windows libraries, dynamic linked libraries, maybe you have a lib in the Linux, you don't, if it is packaged completely, you have no visibilities of that libraries. You trust on your vendors, you trust on your suppliers. They are giving you a package as an image or the firmware or image of the DLL, image of the libraries. You don't know what is inside. You're just getting the tip of the iceberg. You're just looking for the dependencies. You don't know how it is compiled. You don't know which version it is. You don't know which libraries are. Then you're putting an application environment. Then when you get your dependence, which is your runtime dependence, are different. The build dependence, runtime dependence are only executed, which is the build. So when we get into the safety pieces, we have to look at the design SBOM. We have to look at the source in a safety perspective, what the functional safety requirements are for design. What type of information in our source code we can look at the safety in our code, source code, test cases. And how do I know that I'm really following the build, which we talk about the SALS as an example. How do I know that I'm really following the build as the safe? How do I know the build process will repeat the same thing as a generation of the artifacts again? Okay? These are things we should think about safety as part of the SBOM. Let's continue our journey. When we look at, again, the minimum elements, we don't want to boil the oceans. Let's start with the minimum, which is already defined by the CISA, defined by the NTIA first time. We can create the minimum elements at least. Ideally, we can get everything that is available, but start from your names, suppliers, and company names, and version, and all the components can get it together. It's, again, going back to standard, we have available standards in the community. What we are really missing is not implementing. Going back to another standard, which is the ISO IEC standard, which is the 2021, which is now SBOM is the binary images. We can keep track those components. These are available. Now, how are we going to solve this problem? Let's take a look quickly. Modern software pipelines. That's what we're going to start from the bottom up. Which I start to see most of the vendors, OEMs, are building the automation in their tools. How they use, what the techniques they're using it, is basically starting from DevOps concept. DevOps is terminology-wise, it is bringing the principles of practice with all stakeholders, building up a quality software, quality application. Sec is adding a security in it. So based on my work I have been doing for IEEE 2675, if you do DevOps, you don't need a sec. You should have a correct DevOps, should be in it. But we always ignore the security part of it. So now when we look at the pipeline is your end-to-end. It doesn't matter you are building AI systems. It doesn't matter you are building a firmware. Same processes are valid for every system that you are building. But the starting point of the pipeline, it is really starting from your code base. Because when you build up the build package depends on your source code. That's the problem starts. Usually, when you build up any artifacts, if you're using a Python, your Python build is different than using a C, because it's different language. You may have a specific components, but the components will derive based on how you build up an artifacts. So how you build up artifacts that become a pipeline for you. You may have 10 systems, 10 components in your project, but each project will build differently because your code base is built differently. So you need to start from the bottom up. What type of code I have? Start from build configuration. That's what we are saying it. But when you stick only just the build on the pipeline itself, if you don't connect the system, you are limited what you're building as an artifacts in your build components. Again, going back to the firmware, if you look at the typical sensor as an interface, collecting data, feeding back the infotainment, feeding back other components, with a lot of configuration happening. So we need to think about how can I build up the pipeline and inserting a safety within the pipeline. We have to look at the configuration parameters. We have to look at who are changing the specific components. We have to look at the platform itself. Going back to the framework, we have already the framework, but it is not implemented in the pipeline perspective. We can integrate a lot of certification into the pipeline, which is we can certify each of the components as we are moving forward. Goes back to the analogy, as I said, construction business does a lot. Why the software we don't do? Because we don't certify. We always certify last in the game. We just look at only testing, but we should really certify our requirements. We have to look at the requirements architecture. In every phase, we can certify our requirements within the pipeline. Again, pipeline doesn't mean go fast. Use the infrastructure that what we have. Try to insert certification in the process that we do, and adding a certification every component in the pipeline. If we build up a vendor as an example, if I am getting a vendor drop, if the vendor code is analyzed, which is static dynamic analysis, I have a verification of the component level that I have. If I created bill of materials as part of my component, so I'm starting from bottom up, then I'm attaching my binaries, images, along with the bill of materials in a component level, and expanded more and more systems. Now what we have a car, we know exactly what is inside the car. And we know what the components are in the system. So it is really starting from bottom up. When we hook up all together, I'm going to put all slides together, So technically, we are creating the open source libraries across the DevSecOps pipeline. So what I see right now, most of the car manufacturers, OEM parts, they are taking advantage of automations, but they're not there yet creating the bill of materials. I'm hoping, as a future, they can create a bill of materials as they are starting to build and architect and deploy. It is technology is there, standard is there, but what is not there yet, we don't create, we don't automate it. Let's automate it, let's create it. Let's build up those artifacts. It is not, again, it's not a difficult job anymore. If you asked me a couple of years ago, it was difficult. We don't know what we are collecting. Now we know the bill of materials, SPDX format. We know the tools is available. We have the hookup into the pipeline everywhere when we go through. If you are acquiring, ask the dependencies. If you are basically getting a third-party libraries, trace it. If you are building, put in the CI. If you are deploying, put in the CDs. So these are things we should really think about, open source library across the pipeline. That's what most of the OEMs are doing it. That's what people are really making that happen. Going back to my note at the beginning, the organization are able to do 45 days. They are really following the automated pipeline. They're able to find out quickly. They can build the same image with the trusted environment within a matter of couple of days. Integration pushing to the car, that's what is struggling right now. So building the component, updated version, goes back to the integrator, goes quickly. From integrator going back to the car takes a little bit longer. That's the portion is still missing. But whoever does those pipeline, they are able to update quickly. With that said, here's the more information you can collect and take a look. I think I'm run out of time. Maybe I have a couple minutes for the questions. And you can follow me in the blog post that I usually do in the CMU-SCI. The webinar, actually, tomorrow I'll have a live webinar that I'm going to talk about the DevOps pipeline to visualize it. And if you look at this pipeline, how can I collect it and make it visualize it, which is going to be a live tomorrow, which is open source. That said, I'm going to have a time for you guys for a question. Let's have a question. You didn't ask, maybe we should have a question right now. Anybody any questions? Yes.
So far we were kind of trying to keep to have the scope agnostic of the countries.
Correct.
Let's say United States, Japan, you mentioned it.
Yeah.
I'm really curious about China. What they are doing different that allows basically to have the life cycle of their cars significantly faster, not necessarily safer, but faster. And how would you compare with are they doing things right? Are they doing the right things? What is actually different?
So let me think and answer the right way to your questions without going into political discussions.
I'm not political.
Right.
Think about like,
so what is really happening? Let me tell you the truth story. Is an engineer perspective, what I have been seeing so far, they were able to take advantage of automation a lot. First things, they did a lot of good automations. Then, and like one example, I'm going to give you Huawei as an example. They were able to embrace of the agility and also embrace the completely DevOps concept a lot from the bottom up, and they can reuse the components over and over and again. Which doesn't mean they're sacrificing quality. Again, I'm not going to make it generalized, but they are being more agile than ever before that we typically do in the legacy systems. Why? Because when you start something greenfield, you have an option to build up everything much quicker, much faster. If you are trying to change some legacy systems, it takes very difficult. If you look at the car industries, comparing the new manufacturer versus old, and that you see the differences. That may be a good things I see. Another one, if you look at the research publications is coming more in that countries than ever else because it's all automation, all integrated, all data. So I see good coming up, but there's also standards community they're following as well. I don't see any problems. But what is really happening is actually going back to verify and validate it. So if I am collecting any data for particular manufacturing, I think we should still ask about the bill of materials, or we should still ask artifacts, but I see good things is coming out. But it may not be as high quality. It takes a time to build up the high quality. Again, I'm not a quality engineer. What I have been seeing right now, we see a lot of qualities on the functionalities yet. And it's different than the quality of the software and the systems that I see. It's more functional quality. It looks like that type of things is happening, not a software security, it seems to me. I hope that answers your questions. All right. Any other questions?
Thank you so much. I'm engaged in to development application
Right.
for Toyota vehicles.
Okay.
And I completely agree with your concept. DevOps and Scrum and Agile
Right.
is also important in automotive industry. And I try to develop our application by the Agile 2 weeks Scrum development when we are POC or prototyping. So we can successful that, and we approved our application for to become the real product. On the other hand, I think almost all real product development is still waterfall is mainly in our industry. So some reasons exist, resources and regulation, and many testing is needed for 1 or 2 years. But I'd like to change the situation. I completely change to same as a smartphone application. It is very difficult, but I'd like to accelerate it. So if you have some hint or some,
So couples say I can give an advice or an idea. We always blaming the Agile and DevOps, but if you truly follow the Agile practice, if you truly follow it, if you look at the Agile as a mindset, if you follow the Scrum or the SAFe is actually good for the car industry. Many car industries are using a scale Agile framework. Scale Agile framework is foundational, giving a value stream map, getting a capabilities. What is really missing, we are thinking as an Agile. When we go into the application development, we think about the waterfall. I call it a Scrum, water Scrum fall. So you are building a dev as agility, maybe business thinking, but when it comes to implementation, we think is the compliance is blocking us, but as the community of building community, think about the systems lifecycle perspective, we don't educate the auditor first. If you look at all the audit requirements, audit is looking for evidence. Audit is looking for any process, if the process is followed, and evidence has to be generated. What we do as the system lifecycle personnel, we are generating those artifacts as manually. We don't need to. We can generate automatically. Second, our auditors are used to see Excel checklist. We have to change that mindset, make it automated generating, getting their trust. So technically, compliance is not blocking to us. We should have compliance as part of our systems. And going back to the Tesla case, Tesla is because they're approved because they implemented Agility in the company. They implement Agility in the work itself. They build up a self-organizing team. They truly follow it. They also have an incremental work in the safety and also the certification. Going back here, this is what exactly I'm trying to bring the certification in the pipeline itself. So going back to what auditors are looking for artifacts. Can I generate artifacts when I create a model? Yes, it's possible. Can I generate artifacts with my test case? It's possible. If you put at the end, it takes longer. It's becoming waterfall at the end. That's what problem I said. So what I advise to you and as an organization, look at your processes. Look at how much you do manual. Look at how much you do automation as systems. And then automation doesn't mean we are taking people's job away. It's about the trust. So your automation, if you follow it, should generate artifacts to you. Example, Tesla. Example, new car manufacturers like the people, again, many other companies are doing the new SDVs are using those concepts much faster, much quicker. Like Rivian is another one example, actually. They're doing agility as well. A couple other French car manufacturers have started new. They follow the SAFe as the agile practice. They build up the pipeline, and they're able to iterative incremental. Definition of agile means iterative incremental. Means I have to change something, look at incremental, get back and move again. With a smaller cadence. That's what we should do. I hope give some ideas. Again, if I were you, just Google it about the agile and Tesla SpaceX, you get a lot of write-ups and good talks.
Thank you.
Any other questions? All right, so as a last word, if you have any questions, you can connect with me, here's my emails, and we are together in this journey, as I said many times. Let's build up a safe world and better world. Everybody's responsibilities. We cannot work individually, but if we work as a team, we can get the job done. If you have any questions, let me know, and happy to work with all of you. Thank you.